Welcome, everyone, and thank you for joining us today for this D-Zone fireside chat on how to go pipeline free with real-time analytics, sponsored by Celerdata. Today, we'll dive into the fascinating world of real-time analytics and explore a groundbreaking concept, pipeline free real-time analytics, an approach that promises simplicity and improved efficiency for organizations. I'm Jesse, Chief Technologist at D-Zone, and I am thrilled to be moderating this discussion with some esteemed experts in the field of data analytics. We have the privilege of having Andy Oliver, Director of Marketing, hey Andy, and Sita Chen, Product Marketing Manager, both from Celerdata, hey Sita, as our esteemed experts. Their expertise and insights will guide us through the world of real-time analytics and share some actionable examples from successful companies like Airbnb who've embraced this idea of pipeline-free analytics. If you find today's session valuable and want to explore more exciting events like this, head on over to dzone.com/events, where you can access all of our on-demand content. Now, in today's fast-paced, data-driven world, analytics is important. It plays a pivotal role in making critical business decisions and monitoring our applications. There's a lot of different applications for this thing. So we want to drive right into the topic. And Andy and Sita, could you define real-time analytics for our audience? And how does it differ from this idea of traditional analytics?
Sure. So the value of data, as we know, decreases over time. So if the information that's freshest is the most valuable.
Always, yeah.
Rather than doing retrospective analysis and what have you, and think how we can do better next time, you can take action where there's still a chance to make a difference. So something happens, we look at that across our whole system with all of the other data and say, okay, this is the state of things right now. There are a lot of different industries and business cases where this isn't just a nice to have, it's essential. So if you're doing something like IoT or ad tech or something like that, a lot of those cases, this is now. Now, real-time analytics is relatively simple at a small scale. We've all done that, I think, at this point. However, if you look at big, massive scale, this gets a lot harder. So one of the users of Star Rocks in China is Xiao Hongshu, and they're basically a giant social media platform with hundreds of millions of active users. So a lot of times, some of these things over there are at an even bigger scale than you'll see over here, just for population. Advertisers run ads on it, and that's the main way they make revenue. So you can kind of think of it as ad tech in that way. And some of the things they want to do is monitor the performance of the ads and use it to tune things like the recommendation algorithm. They've also got external facing analytics. So advertisers want to see how well their ads are doing, and they're probably not waiting to find that out at the end of the month anymore. So they want to see right now, how are my ads doing? So the value of the real-time data is, as long as the ads are running, it costs money. The fresher the data, the faster everyone can react, thus in a way preventing losses and increasing everyone's profitability. Now, when you think about this, though, to make that happen, your analytics system has to take in data in real time. So it's got to be able to handle, inserts and upserts and changes the data in real time, and a massive amount of concurrency. And traditional analytic systems don't handle concurrency well. It used to be, if somebody asked me, I'd say analytical systems have one user querying a lot of data, and transactional systems have lots of users querying very little data. Well, now we have analytical systems where you have lots of users querying lots of data. So doing it in real time is really about shrinking that time between when the data comes in and when somebody actually analyzes and looks at the data.
Because time is money and it's valuable, right? Sita, what do you see on your side?
Yeah, so we're probably gonna talk a little more on the technical side, right? So how is real-time analytics different from a traditional batch analytics, right? And I think the ultimate goal of real-time analytic is is not only to have fresher data, is actually the entire pipeline from data generation all the way to to actionable insight, to action, to actually make a difference, right? When it's still not too late, right? And this whole pipeline consists of many different steps, right? From data generation to data transformation, to data ingestions. This is sometimes optional, but and to analytics, and to visualization, or automated decision making, from another software or another application, right? And each step of that needs to be really fast in order to meet the business needs, the tight time constraint, right? And this time constraint really often requires specialized tools to tackle these problems, right? And let's take ingestion, for example, right? Ingestion into your OLAP system. OLAP systems are designed to run complex aggregated queries at scale, right? So they're often columnar storage, so they store data in a columnar format, right? And in big chunks, right? And updates or data inserts are by row. So it's really difficult to do them in a short, in a very short interval and very frequently. For big batches, they're okay, right? And especially when you put in, data upserts, and how to how to change a tablet inside, the storage engine, and that's a huge challenge, right? And apart from that, is the whole pipeline, the query side is important too, right? You need to have very low latency to meet the time constraint, right? And for a batch job, back in the day, we're using, Hadoop, run a map reduce job. You run the job and go get a coffee, get a solid pizza, take a 5-hour nap. That's, you're probably still running. I'll be okay with it, right? But for real-time analytics, it's really not the thing. So the whole pipeline from the beginning to end is all different from traditional analytics, and we can kind of unwrap that as we go in this talk.
I love that. And it's funny. You said, back in the day, I'm like, that was yesterday, man. Back in the day was DBase and Fox
Yeah.
Pro in like 1996. He
Yeah.
knows what I'm talking about. But you're right. Data's changed a ton since then.
Yeah.
Right. And so the idea of database specialization, right? We went in the 90s and the early 2000s to the big Oracles and SQL servers of the world, and you're trying to do everything against them, and not mostly designed for transactional. Then you've got your OLAP databases, a lot like what you got for analytics, columnar storage and stuff. You've got some, your relational databases, which are storing, different relationships for like social networks. Hadoop, which to me, I still thought was new. Thanks for making me feel old, Sita. Appreciate that. But I want to jump, if we can, and take a minute and talk through pipelines, right? This idea of data pipelines has been around forever. And it's a critical thing in real-time analytics. But tell me how we got here. Like, why now have they become this source of complexity and expense, and we're innovating on that side? Like, how do we get here?
Yeah, so pipeline in terms of real time and batch analytics are different, right? And real time, you expect everything to run really fast, so there typically not much going on in there. But doing everything in real time makes it expensive, right? Let's take a step back and talk about joins and denormalization, normalized tables, right? Normalized tables means you store your data into multiple tables and have relationships between them, right? That has been the a good practice or the standard since the invention of database management system. That was probably in the 1970s, right? And just say you have like an order table, right, with a customer ID, and you would have another customer table, storing all of the customer detailed information, and have an ID in that table linked to the customer ID in your order table. And that's considered, that's still considered a good practice and the de facto way of doing analytics or storing data, right? And data is normalized in this natural format in a star or in a snowflake schema, right? But in real time OLAP space, that's kind of different, because a lot of the OLAP databases, real-time OLAP databases, are not optimized for join operations or multi-table join queries, complex queries, right? And so the database actually rely on the data practitioner, on the user to do denormalization of the data before it hits your OLAP serving layer, your real-time OLAP serving layer, right? So basically to pre-join multiple tables into a flat table, destroy your star or snowflake schema and into a flat table schema. And that is a huge pain because doing everything stream or real time restraint, right? You cannot really use like traditional tools like batch tools like a Spark, run a Spark job, right, on a partition, do a partition swap, and that's not really viable. So people are turning into those stream processing tools where every operation is incremental, right? Incremental means that the amount of computations is only depends on the new data and not depend on the historical data, right? So you only compute what's new, but those tools require specialized engineering skills, actually require coding, in Java, in Scala, and
Yes.
those are not that easy to use. And a stateful operation like a join or a big group by in the stream processing tool, that's not easy to maintain. Just select the right window size can be a pain, right?
Yeah.
And so this, I think, makes the data pipeline, or specifically pre-processing pipeline in real-time analytics, the most expensive part, or the most complex part in real-time analytics.
That's true. And the stream processing stuff was invented to solve some of those problems, but it sounds like
Yes,
it's adding
exactly.
complexity.
Yeah, it's adding complexity. It's turning people away from doing real-time analytics because they
Yeah.
need to do those big denormalization, like joining like a billion row with 100 million rows in a stream stateful stream processing job, and that's not easy to do. That's nowhere
No,
near
it's
to do.
not. And
Yeah.
and that's what's fascinating to me is I think through, like you're saying, Java and SQL, and I'm getting excited, because I know how to do it that way, but it doesn't make it as usable for everybody,
Yes.
which I like where the conversation's going. And I want to dive a little bit deeper, if I can, into these challenges that we're facing with these traditional data pipelines. Like, how do they affect the overall performance of the real-time analytics?
Yes. So what we just went through was the pure technical part, right? Just to engineer, to implement that pipeline and how to maintain that pipeline, all the technical difficulties, right? But it actually is not good for your experience at all, because when you denormalize something, you need to know your query pattern beforehand, right? And lock your data into a rigid single view format, right? And
Mm.
every time you want to, there's something change in your business, you want to add a column to one of your 15 tables that you joined together beforehand, right? You need to reconfigure the entire pipeline. That's a lot of engineering effort. And also you need to backfill all of the data in. Just imagine you have like 100 terabytes of data. That's going to take hours to do, even with a big cluster, right? And that this really makes your analytics workflow rigid and not flexible, right? Really not good for real-time analytics where everything is changing so fast.
I see that. And I thought it was funny. You said, but it's only a problem when there's a business change and reconfiguring the, what are you talking about? The businesses don't change often, do they?
They do. They do. I mean, I mean,
Of course they
they
do.
actually
And they
do.
should, because that's
Yeah.
what it takes today to stay competitive, right?
Yeah, to add a column, that's not a big ask, right? Or to, remove a column, or, change a data type or something. That's not a big ask. But if you build a denormalization pipeline, and that is technically a big ask, but
It is.
it's so normal in in everyday business. You just change something, little things. Right.
So I want to keep digging here a little bit if I can. We had in the title this idea of pipeline free real-time analytics.
Yeah.
We talked about analytics, how we got here, some of the big issues that we're having with it. But I want to know, can you explain really to me, if you can, what that entails? Like, what is it? How does it simplify the process?
Yeah, sure. So technology always evolve, right? And with a lot of the new tools at hand, and with a lot of engineering effort from the database provider, it's actually entirely possible to do joins on the fly, instead of like pre-join everything and just do joins on your server on your serving layer. Right. And here I want to kind of introduce, the database or the open source OLAP database, Starox, right? Starox is built for this kind of workload, right? It has a columnar storage and it's SIMD optimized. It has a cost weights optimizer, which is really important for large scale join operations, right? It's completely MPP. It has an MPP architecture, so it supports all kinds of join algorithms, right? And it's built to do joins on the fly in a real time environment, right? And let's you can take a look at some benchmark here. So the first one is the SSB benchmark test, right? SSB is, if I want to conclude what that is basically for your it's like mimicking like a reporting or dashboarding kind of scenario, right? Where the queries are multi-table, but they're not that complex, right? And this is really a common, representative benchmark for real-time analytics use cases, right? And just be aware, there are actually two variants of this SSB benchmark test. The first one is the original one with multiple table and you do joins on the fly, right? And because a lot of the databases cannot do join, and there is a variant actually made by the folks in ClickHouse, right? And so they denormalize the whole thing into a big wide table and do single query instead of multi-table query, right? And join is expensive, right? And now let's look at some results, right? And you can see Starox flat, and everything with a flat is saying that it's a single table, right?
That big single table, right?
Yeah, everything's in single table. And when I say multi-table, Starox is the only one out there because Starox is actually the only one that can finish it. It's multi-table, right?
So am I reading this right in that Starox is joining from multiple tables faster than Apache?
Faster than Druid.
Is
almost
doing,
as
wow.
Yes. Almost as fast as
table.
ClickHouse, right? And and in a single table test, we're the fastest, and that's actually where ClickHouse shines. And but for multi-table query, we're close. We're close to ClickHouse, and we're
close to ClickHouse in a single table. So
in a single table. So it's not even a fair comparison. Yeah, it's not even a fair comparison.
And it's huge. These are giant. These are multiples of speeds, not like 10%.
Yes, exactly. And the thing is that this by itself eliminates your denormalization pipeline, right? And so you get all of the benefit of having the same schema between your data source and your OLAP layer, right? And so you can do all of the change instantly without like meddling with any kind of schema change during the pre-processing pipeline. And that is kind of huge, right? And yeah, it is a little slower than ClickHouse, flat, but it's expected, right? Because join is a very expensive operation.
Oh my goodness, yes.
Yeah, but Starox and all of the other MPP, true MPP architecture database are built to scale horizontally, right? You add nodes, it's gonna scale near linearly. So it's gonna near linear scale, right? Almost linearly scale, right? So you just take your whatever you're spending on your data pipeline, right, and redeploy that into more Starox nodes, and it's gonna run faster, and it's gonna be cheaper, and your business is gonna be so much more flexible, right? It's gonna be so much more flexible for your business change, right? And this is more like more like a real time. Let's just for the fun of it, let's look at TBCDS. TBCDS benchmark is it's really representative for those really heavy ETL workloads, right? Like 3,000 line with many joins, many group bys, and very complex queries, right? And this is on a terabytes of data, and we're 5.54 times faster than Trino. And Trino is, it's a data lake query layer, right? Yep. And this is actually querying the same exact data set on Apache Hive, right? External data. And we're 5.5 times faster than Trino on those extreme join complex queries,
Hmm.
right? Yeah. And yeah, so it sounds simple, right? So how do you do it? So, you don't want pipeline, you just join on the fly, right? But for real-time analytics, there are like more demanding scenarios, right? If you are like, if you're serving like Xiaohongshu, like the case we talked about before, right? They're serving a bunch of advertisers and they have in the high hundreds of QPS on OLAP queries. And that's a lot of QPS. That's a lot of queries for OLAP, right?
Yes.
Like group by queries. So yeah, sometimes even with the best optimizer or with the best query layer, it's not really possible to keep up, with hundreds of QPS, right? But there are other ways other than adding a stream processing tool to your data pipeline, right? And there's a thing called a partial update, right? And so basically is, say you have 100 columns, right? And you have two streams, like two Kafka topics you want to denormalize into a big flat table, right? Instead of doing the denormalization in a separate job, right? You just, 100 columns and one stream updates the 50 and the other stream updates the other 50. Right. And this has been, it sounds simple, but it's not actually that easy to.
It was so easy when you said it.
Yeah,
It
it's
makes
not
total
that easy
sense.
because everything stores in a columnar format.
Right.
Everything stores in a columnar format. And this update to make that efficient enough to be enough for production use is not actually that simple, right? As far as I know, including Staros, there's only 2 databases that supports this, and Staros supports the best out of all, right? And this is kind of like the plan for the way to do it for your high concurrency workloads, right? Where the requirement is so extreme that Staros can't even keep up, right? For partial update. Yeah, and we can look at an example, right? Example of Airbnb. Airbnb's metric platform is called Minerva, and they actually holds, I think, from last year 6 petabytes of data in their metric platform. And before they were using Druid and Presto and Spark as their query layer, right? And the data is actually scattered all over the place. And because Druid cannot really do join very fast, so they needed to denormalize everything, right? Denormalize all of the tables into a big, wide table, flat table, right? And every time they want to change a column, that's from them. Every time they want to change a column, it takes hours or up to days to do it. And they spend so much engineering effort into implementing and maintaining those denormalization pre-processing pipelines, right? And then they moved to Staros, and Staros became their kind of like a unified query layer, right? Because Staros is good at joins, so they just say, we're just gonna do joins on the fly and get rid of all of the denormalized pipelines, right? And by last year, actually, they shared it. It's a webinar with us, and there's only 20% of the table that is still denormalized, and all of the other tables are normalized, and joins are done on the fly. So this saved them so much effort, right?
Yeah.
So they're actually doing joins on the fly, joins on 6 petabytes of data,
And architecturally, it's much more simple.
Yes, it's much more
simplified
simple.
the architecture a lot. I love how Andy's grinning, but that's
Well,
a huge
but also
deal.
think about the cost. Think about the
money
cost.
wise, yeah.
Because if you're when you query data, or when you have an analytical system, most of the time, most of the data isn't even queried or isn't even read. It's the parts that people are interested in.
Yeah.
So if you're pre-joining that data, in order for it to be efficient, you're basically going to pay. You just set some money on fire, create a nice hot fire, and with that nice hot money file, you bake your data cake into a big flat table, so that some small percentage, or in some cases small percentage of it, can actually get eaten. So this saves your money fire.
Yeah.
That's a big deal. And the whole idea of pipeline free, I'll be honest, I was skeptical. It makes a lot of sense. It's simple. I like how it makes things more simple, right? The biggest issue that I see with software systems, especially data systems today, is they, they keep getting more complex. And as we fight to make it more simple, it becomes more useful and faster, which I love, right? Um, and as we talk about Airbnb here, which is super exciting, and to be honest, a lot of people came here to hear this piece, right? Sita, is there anything else you want to point out on this one? Because I was excited. Andy got to pipe in, and I want to ask him a question next.
Yes. Yeah. So for Airbnb, they have been using Starbucks for the past like two years now. And if you want to learn more about Airbnb's use case, you can hit up, celerdata.com/blog, and there's a blog post, and
Oh, cool.
in the Celerdata YouTube video, and there is one they did a webinar with us and just talk about how they went pipeline free
Awesome.
with Starbucks on their real time analytics workload, and that's with their the Minerva metric platform, and with their trust system, so anti-fraud kind of that needs to be real time as well. Yeah, so welcome to check it out. Yeah.
That's awesome. All right, Andy, you've been too quiet. I'm gonna ask you a question, man. I want you to explain how this whole pipeline free real time analytics really helps with efficiency in comparison to the traditional approach. I mean, we talked a little bit about some of the technical stuff. Give us some of the other stuff.
One of the things in the Airbnb webinar that they talk about is how long it used to take them to add just a new metric. So it used to take weeks. Now it doesn't. So one of the things is things change. People want some new analytics. They want to know some new things. Things evolve. People want to approach at least interactive analytics. Being able to add a new column, being able to change something is huge. One of the things, Sita mentioned the joins and some of the other optimizations. Another is being able to do pre-aggregations and things like that with materialized views. So rather than having to pre-aggregate, you can also just do that inside the database. Just an aside for a strength of it. So getting rid of these denormalization pipelines saves you the money I mentioned. So we can get rid of our money fire that we bake the cake with,
which is a good thing.
Yes. Most people don't like money fires, but I'm thinking of some rap videos where they light the cigar with one or something like that. But I think in general in business this is frowned upon.
It's frowned upon. Yes, frowned upon.
But think about this. Think of the poor guys maintaining these platforms and having to handle all of these different denormalization platforms, the timing of the jobs, all of the different stuff that they have to do to make this stuff work. That stuff's complex. It's brittle. And whenever you have a lot of moving parts, a lot of things break. So keeping it simple means it's keeping it more reliable, means fewer calls in the middle of the night. And if you have your table schema roughly the same or similar to what you have at your initial source, with no transformation during this pre-processing, whenever you need to make a change, it's simple. You add a column over here, you add a column over here. Life is far easier.
Easy schema changes, moving at the speed of business. I like it.
Yeah.
Being able to change allows our business to change, to what I was joking with Sita earlier about, because businesses do change and we have to make those things fast. And then reducing the maintenance, we always underestimate how much it takes to maintain some of these pipelines, right? And we joke about the money fire, and the money fire in terms of platforms and additional query layers and stuff we were talking about with Druid and Presto and Spark.
Yeah.
But the people cost, the human cost of someone having to investigate that stuff is huge. And Andy, give me some ideas. Like I want those out there listening. Thank you for hanging in there with us. I want them to have some actionable steps. Like what would you recommend for organizations who have seen this and they're like, okay, I'm ready to work on some pipeline free stuff. It sounds great. What do they do next?
Yeah. So, I mean, I think everyone should investigate reducing the complexity of their systems by having a database that can do joins and do materialized view. Hopefully they pick Starrocks, but hey, it's open source. I think one of the big things to think about is whether or not real time's right for you first. So in some, if, and I think in the US we tend to batch a little more. I think if you're in a faster moving developing economy or whatever, and you didn't have any analytics, you go straight to real time because why wouldn't you, kind of thing.
Yeah.
But if you're already there, if you're already doing analytics, you should evaluate the business case and say, how can the business benefit from real time? And you need to think outside the box, because sometimes it's like, well, we've always done this kind of batching and what have you, and that's just how it works. But it's like, not that many years ago, when you shipped a package, you could get the tracking information, but it kind of showed you when it had shipped. It showed you when it had arrived at your local shipping center, and it showed you when it was delivered. Nothing in between. You had no idea where it was or when it would get there in reality. And now we take for granted these new kinds of capabilities. So think outside the box. But how can the business benefit from going real time? Then you need a database technology that can handle inserts, upserts, and concurrency. If you've got something that's totally inflexible and you have to do it in this pre-cooked format, then you're not going to be able to do this. You want to look at joins and materialized view and ELT as opposed to ETL. ELT is extract, load, transform. So basically doing the transforms inside the database versus having this transformation pipeline. As the data gets there, it gets transformed inside the database. This is going to be a lot faster than doing it in steps and across several different tools. Yeah. So ELT can be essential if you want fresh data, lower operating costs in real time. Because one of the things we were talking about is these different transformation pipeline steps, they all take time. So if I got data over here, I do all these different transforms to flatten it out. By the time it even gets the database and we haven't even queried it yet, it's old. Right. So, hey, you need to be able to do these things. We hope you pick Starrocks, of course, and you can deploy operationally in the cloud, such as Celerdata's BYOC offering of bring your own cloud offering of Starrocks. You also want to consider lock-in. I've always favored open source because I don't want somebody to pull the rug out from under me at some point. Yep. I think I still have like OS2 flashbacks or something.
You just dated both of us.
Yeah, I have OS2 flashbacks where things just, directions changed and things went sideways. And then if you were on that and it was then abandoned, and then you were like, okay, what do I do now? Rewrite everything. I'm not going to talk about 1632-bit thunking because that'll.
Oh my goodness. OS2 referencing OS2 or OS2 warp was enough. Thank you.
So look at your sources, look at how you feed your data to the analytic systems. This may mean something like so if you're going from batch to real-time, Kafka or Flink or something, to ensure your data makes it to your operational system and your analytical system in the time you need, or both at the same time, or one then the other. And then consider user experience. Look at real-time dashboards, user-facing analytics. So maybe right now you've got everything where some analysts run these batch reports at the end of the month. Well, what are they doing? Well, they're informing the customer or something like that. Well, what if you just let the customer look? Then would you have to do all that? Consider interactive analytics. So this is kind of on top of the real-time experience where I let somebody be able to just explore because my database can handle it, right? I let somebody explore rather than I have to go create these pre-cooked reports and run them in batch or whatever. I let them just drag and drop and what have you. If you can do joins and some of those things, you can consider that kind of experience.
Now, what about smaller companies, right? A lot of this stuff, it's big, it's open source, it's going to need some people to kind of monitor it and use it, maybe even maintain it. What about smaller companies with more limited resources?
So, I mean, with this new technology, the cost of goods and services go down. So any place where we talk about better performance, we show you benchmarks and we say, oh, look how much faster that is. That's also, look how much cheaper that is, because it means you need less servers to achieve the same performance.
Yeah.
So pipeline-free real-time analytics, or eliminating denormalization or any of the streaming stateful operation, the pre-processing stage, all of these remove the biggest factor that contribute to differences in cost between real-time analytics and batch analytics. So this stuff makes it accessible for smaller organizations, less well-funded organizations, to where right now the reason they're not doing it real time is because it costs too much.
Yeah.
Well, we just brought the cost down by a lot, potentially hundreds of percent. Well, maybe you can actually do real time now, without a streaming pipeline to maintain, without having to, that's the other thing, is you don't have as many people to do these things. So without a streaming pipeline, without having, while having the flexibility to perform schema changes, without reconfiguring the pipeline and doing all the data backfilling. So this makes this way more accessible to a lot more businesses. Yes, your Airbnbs picked it because they can sit there and say, okay, yes, we want to do this faster. Yes, we want to maintain less complexity. Yes, we want more real time or what have you.
Right.
But a huge motivation is, yes, we don't want all these extra servers, because when you run at the scale of an Airbnb, and I say I can cut, 25 or however many percent servers,
Right.
this, few hundred million here, a few hundred, no, yeah, a million here, a million there, that adds up real quick to some real money, right?
It does.
So at the smaller scale, this makes this kind of technology, this kind of real time, and it makes new business models more possible.
Awesome. And I know we're running low on time. So we do have your slide on different resources where people, those of you out there who want to learn more about this topic, website, blog, there's a free trial, Slack URL, all kinds of stuff. They can connect directly with you two guys. And we'll put that information out there. But the last question, I do want one more to hear from y'all. Like, what advice would you give to the people in the business who are leading the data initiatives for these organizations that are just beginning to explore real-time analytics? Like, let's leave everybody with that so we can start to get started.
So although real-time analytics has become a lot cheaper, there's still some extra cost associated with it. So first, evaluate whether your business would benefit from going from batch to real time. Yes, eliminating all these pipelines makes it a lot easier, a lot cheaper, a lot more feasible, but hey, it still costs more to do real time than batch. There's some really clear-cut industries where real time is a clear winner. IoT, smart grids, ad tech, gaming. One of the biggest users of Starrocks in China is Tencent. They use it on like the biggest game in the world. Logistics, so anytime you're tracking assets in real time. Manufacturing, where you've got real-time supply chain, factory control systems, all that kind of stuff. And then financial transactions, including crypto. A lot of the crypto industry likes to use a technology like Starrocks to yes, like Star Trek. Starrocks is like Star Trek technology here. It beams your data up. But they like to use technology like Starrocks to look through the blockchain and analyze the blockchain and figure all that kind of stuff. But ultimately it's just like any financial transactions or something where you need it at high volume and you need to know what's happening now, for whether it be money laundering, fraud detection, any of that kind of stuff.
Awesome. All right. Well, thanks everybody for joining us. We had a great discussion. Started out at the beginning, kind of technical. Seated walked us through a bunch of different things on the technical side and then more on the business side. But the biggest thing for me to take away was the significance and feasibility of this idea of going pipeline free. So thank you, Andy. Thank you, Sita, for sharing your expertise and experiences, and special thank you to Celerdata for sponsoring this chat. As you all out there continue your journey in the world of data analytics, we encourage you to explore the ideas discussed today and apply them at your own company. If you enjoyed our discussion again and want to see more events like this, just go to dzone.com/events to see all of our on-demand content. Also, if you will, please stay with us for just another minute, take a quick survey. Just like your data pipelines, we're always looking to be more efficient and to improve and see how we can do better. Thank you, everyone, for joining us. Bye-bye.
Thanks again, Jesse. Bye-bye.